right? This would be probability of more than 3 shots would be this first one. So if you notice though, it has to be equal to when you do the calculator. So you could either do this 1 minus the probability, because if it's greater than 3, then that's 1 minus being less than or equal to 3, the opposite. Probably the easier way to do that would be, think about if your x is greater than 3 and it's discrete, you can't be in between, then you jump up to the next option, so that's greater than or equal to 4. So you would go to binomial CDF, which is, if you scroll all the way down or you type B, number of trials is still 5, my probability of success is 0.7, but now my lower bound would be 4. So your calculator does equal to. So you can't use 3 if it's just greater than, if there's no equal to sign. And then my max is not infinity because I'm making 5 shots. So my upper bound is 5. And it would be 0.528. 528. Same thing here, if you want less than 3, you would have to change that to be less than or equal to 2 shots and do the same idea. But your lower bound would be 0, right? The lowest amount of shots you could make is 0. My upper bound would be 2. So hopefully that made sense. I feel like I got a little tongue-tied. Then if it talks about if you know that it's a binomial situation, you checked your bins. You know the mean and the standard deviation of that distribution using these formulas. So if you notice, it says if x is a binomial distribution, this is that same probability that this formula is binomial PDF, right? The probability of having x equal amount of successes. So if you were going to do greater than or less than, you would have to add up each option, right? If you were going to use the formula, if you wanted less than or equal to 2, well then you would have to do what's the probability of equaling 2 plus the probability of equaling 1. And that would get a lot more. But you do need to be familiar with this format, because they might, never mind, I was about to talk about multiple choice, but that's not your test. So I wouldn't really worry about that. But this is the same answer that binomial PDF gets you. This is how you find the mean of your distribution, and this is how you find the standard deviation. You should be using N and P if it's binomial. And then it says you can use a normal distribution instead of binomial if it passes large counts, which are large counts is LCC. N times P is greater than or equal to 10. That's the number of successes is greater than 10, and N times 1 minus P is greater than or equal to 10. That should look familiar. We use that when we're doing proportion test or interval. I don't know if we touched on that when we did this. It's not super important, but it's there if you need it. Then the last thing was geometric random variable. So that is talking about what's the probability of taking a certain amount of trials to get your first success. So you're looking for words like first or until. So for example, if my free throw percentage is 70, if I said what's the probability of it taking 5 shots until I got my first shot, my first basket, that would be geometric PDF, right? So that would be what's the probability of it taking 5 shots until my first basket. So you would do menu, probability, distributions, and then it's geometric PDF is H. My probability of success is 0.7. My X value is how many times did I want it to take until I got my first one was 5. So it's a 0.005 chance. And again, you should be labeling all those numbers. And then if I wanted to say, what's the probability of it taking more than 5 or less than 5? You would do geometric CDF. That would be probability of it taking more than, or it could be more than 5 shots, or it could be less than 5, greater than or less than, to make your first success. And again, you'd have to jump up, right? So, or down if it's just more than or less than. For example, if I go back, but now I'm going to go to geometric CDF, which is I. My probability of success is 0.7. Now, probability of it taking more than 5. So more than 5, my lower bound would be that it took me 6 shots to make my first one. Now, I could take an infinite amount of shots until I get my, there's no boundary on how many shots I can take until I get my first one. So you can use infinity on this one. The 0.002. Or if it was less than, your lower bound would be 0 because you can't take negative shots. And the mean of a geometric distribution is this formula, which that used to not be on your formula chart, but now it is. So this is the official formula. That's like geometric PDF if you needed to do this by hand. And then this was the formula for the mean of your geometric distribution, and this is the formula for standard deviation, which that's not on here because they used to not ask about it because they didn't give you the formula, but now they do. It's the mean. Oh, I should have probably done y, because that's y, but standard deviation of geometric distribution is the square root of 1 minus p, all divided by p. So that is an overview of chapter 6. It was about random variables, transforming, combining them, and then binomial and geometric. So let me know if you have any questions as you're working, and have a great rest of your day.